Hello and Assalamualaikum. So today I will present about my final year project. So before I start, I will introduce myself. So my name is Muhammad Arif bin Ahmad Lutfi. Uh, my supervisor for this project is Prof. Dr. Zuria binti Ibrahim. And then my title for this final year project is Productivity Improvement Using Six Sigma Concept, a case study production of leaf spring in automotive industry. So we move to the slide. So I will recap about the PSM1 from chapter 1 until chapter 3. So first of all, introduction. So this case study explain about leaf spring production manufacturing, and then this case study was taken based on Belton Spring, Sdn Bhd in Perak. So for the first picture, this is the how the look like of the leaf spring, and the second picture is about how the leaf spring installation at the heavy duty transportation, and the function of the leaf spring is to absorb and relieve load slowly as a spring element. Second is avoid transforming highest shock vibration into passenger, and there is a process of leaf spring. So the complete leaf spring will through a section A, section B, and section C. But in my case study, I will focus on section A. And then this is a problem statement. So to get a problem statement, I create this form to get a problem statement at the section A line production. So in this defect analysis form, we have a several type of process, which is eye forming, temper rolling, cutting, and punching. And then we have amount of defects, demand per day, total of defects, and operator. So the data was collected from 28 October 2019 until 10 November 2019. So totally for 14 days. So after that, there is a graph for total defect in leaf spring productions. So as we can see here, the eye forming process get the highest defect of leaf spring with 54%, and then 25% for taper rolling, cutting 13, and punching 8. So the conclusion for this problem statement is we can see as eye forming got the highest. And for the objective and scope, objective 1 to identify the critical defect at production line section A, to analyze the root causes of critical defect at production line section A, and objective 3 to provide solution for the critical defect at production line section A. And for the scope, this study focused on eye forming process, which is at section A in production line. And then this case study focused leaf spring of the 3 different shape of eye blade, and then application of Six Sigma method to give the appropriate solution to reduce eye forming to defect at production line. So literature review, I choose one. For the authors Patiban and Raju in 2015, the finding about productivity. So they said for the survival and breakthrough of work in the automotive industry in order to improve productivity. Okay, we focus to next slide is methodology. So this is a project flow. I will explain roughly. So for FYP1, clarifying problem statement, and then establishment of project objective, establishment of project methodology, and then for FYP2, we have objective 1, objective 2, objective 3 to achieve. So for objective 1, I have a data collection. So I did observation at production line, interview with a QA supervisor, and then with QC operator there. So I have a defect analysis form, and then I have a data analysis to identify the critical defect, and then for the result, we can identify the critical defect at production line. For objective 2, we start with a data collection, observation at production line, and then I create a collective form, data collected for 2 weeks. And then for the data analysis, identify the root causes of the critical problem at production line section A, and the result is root causes of the critical problems at production line A is identified. And the last for objective is we start with provide of appropriate solution at I-forming process based on the root causes and the implementation of Six Sigma method at I-forming process. Okay, this is that we have to focus result in discussion, chapter 4. So for objective 1, so my objective is to identify the critical defect at production line section A. I also want to mention at objective 1, define a major stage. So I create this defect analysis form to achieve objective 1. So in this form, we have three type of shape: standard eye, Berlin eye, and reverse eye. And then we have a two type of defect, which is overheat and accuracy of diameter. And then this form also was collected by within 2 weeks from 4th November 2019 until 17 November 2019. So after 2 weeks, within 2 weeks, so this is the pie chart that I can show to all of you. Defect analysis form. We can see that accuracy of diameter with 78% and overheat with 22%. So as we can see here, lack of accuracy of diameter facing the highest defect at I-forming process machine in production line section A. And then this is objective 2. My objective 2 is to analyze the root causes of critical defect at production line section A. So at this objective, I already moved to analyze stage. So I create this form, quality form. So the main here is a Ishikawa diagram. So we have a problem here, root causes, contact action. So the data was collected from 9 March 2020 until 22 March 2020. So within 2 weeks, a frequent problem that occur at I-forming process is lack of accuracy of diameter, as we can see at objective 1. So what the root causes is after the 2 weeks, so I can see that men do not check properly the size of bush pin that requirement for the I-forming formation. Second is machine. There is a dent at bush pin not in a good condition. So after a discussion with the QC operator at that company, so I suggest my solution for this problem. So the contact action is I have a two solution, which is change a new bush pin. The second one is update or renew standard operation procedure. Okay, so for the objective 3, to provide solution for the critical defect. So since I have a two solution, so this is the first one, change new bush pin. And I also want to mention this I already moved to improve stage. So I choose a graph alloy. So graph alloy defined as a graphite metal alloy and low coefficient of friction, suit with temperature, with a high temperature, and the lifetime cost, and a reduced maintenance and downtime, and then they still reach temperature up to 750 Fahrenheit. So this is a current material, and then this is a proposed material. So the current material, they use a bronze. Okay, and then for the proposed material, I propose a iron. So there a difference between these two materials at the tensile strength, crushing strength, and application. So as we can see, current material 38 MPa, crushing strength 170 MPa, and application bearing, steering, and contact. So at testing strength for the proposed a little bit higher with 41 MPa, and crushing strength is 170 MPa, and application submerged bearing and contact. So why I choose graph alloy is chosen. So more than 10 years without interruption. So we don't need to change quietly. And then second is the range in annealing furnace can reach 1200 Fahrenheit, and then even the bearing support at the outside still can reach 750 Fahrenheit. So this is a support journal that I find to support why I choose a graph alloy. So for the second solution is update standard operating procedure. So since the operator always do a mistake to choose a bush pin, so I want to apply pokayoke. So pokayoke, as we know, is a terms that from Japan's, which means mistake proofing. So to eliminate product defect by preventing about the human error. So what I want to apply is apply color coding or labeling at tools or equipment. So this is the first picture that I want to show to all of you, that color coding at tools. So this is, I give an example to a bush pin. So I choose the red for 10 nm for the diameter for the bush pin, blue 20 mm and yellow for 30 mm. So operating procedure for I-forming process. So this is the current, and then this one is a proposed. So they have a 9 steps, but for the proposed SOP, I just focus at the step number 4, because the step number 4 you choose bush pin for the required dimension of the material workpiece were shown in the drawing by color. So I already put the color that I give example. Like I said before, red 10 mm, blue 20 mm and yellow 30 mm. So I think with this kind of apply that I want to apply, make it easier to operator to see which bush pin should be installed at the machine. So we move to the control stage. So to control it, I want to apply weekly check and maintenance. So do a weekly check to a bush pin condition, is that still in good condition or no, and then cleaning up the bush pin after use it. Put the bush pin in the place provided in a good condition. This is the first for bush pin, and for operation procedure, to avoid the wrong bush pin installation, the operator should double check before running the machine. And last but not least, the conclusion. The study has successfully achieved the objective by implementing Six Sigma DMI methodology in production line section A. So basically from objective 1 until chapter 3 successfully achieved. And then the problem involved at lacking of accuracy at I-forming formation, where the causes have been found and the analysis have been made to find the root causes of the problems. And last, the improvement had also been made so that the problem could be solved with the appropriate solution and method. Thank you.